Today I am talking with Bret Hudson and Ben Visness. Both have over a decade of experience doing practical web development. Bret is a senior engineer at Vercel, and Ben works at Mozilla on Firefox's WebAssembly engine. I have them both on today to give me a crash course in web programming. This is a different sort of conversation than I presented here before. I put this together because I'm currently working on a project in the web programming space, and I felt that I needed to gather more advice from individuals with practical experience. So here I take on a role of a beginner with just enough experience to begin piecing together ideas and asking questions, but not enough to feel a very strong mastery over even basic concepts. To anyone in my audience who, like me, feels an internal allergy to web programming, I hope you will consider the conversation here with an open mind. I still have my share of complaints to register about the way web programming works, but for the purpose of this conversation, I wanted to set aside my instincts to pick everything apart and instead try to just get a better idea of how this space works now as it currently is. With the way this conversation turned out, I think it is especially suited to anyone who, like me, is comfortable with programming close to the metal and is now curious to look from that perspective into the world of web programming. Because of its length, I've split this conversation up into two parts. In part one, we talk about primarily web APIs and databases. We touch on some low-level details regarding HTTP, practical matters of working with web APIs, and sorting out some of the jargon surrounding HTTP web APIs. We talk about the reasons web programs tend towards using databases, the process of choosing a database for a small project like mine, and how to think about the way that a database stores and retrieves data for me in the programs that I write that work with a database. With all of that, here's part one of my web programming crash course. I'm here today with Ben and Bret. Hi, guys.
Hey.
Hello.
Hi, so I've got you guys on here because I'm looking to get a crash course on web stuff, and the first two people who came to mind that I know love to talk to me about the web programming stuff that they've done were the two of you. So thanks so much for coming and indulging me on this. This is kind of an interesting, different format from what I've done before, but I think it's going to be a lot of fun. So we're not going to talk about my project a whole lot, but I just want to kind of set the stage so that everyone listening knows what's going on. I don't do any web programming or haven't before. I barely learned a little bits of it here and there from things like you guys telling me about what you like about it or other random stuff I've picked up. And I've recently started getting into it, but I'm still a total noob. Like there's lots of stuff that's like, maybe there are low-level details here I should know more about that I haven't had a chance to learn about. Maybe there are conceptual things here that I should know more about that I don't know anything about. Maybe there's workflow stuff here that I'm doing in a really dumb way. And it's pretty obvious to me that I'm doing all of it. Like I have a lot to learn on a lot of that stuff. But I've also spent just enough time in 3 or 4 weeks digging in and chipping away at stuff that I feel like I have a good enough handle that I'm in that useful phase where I have all these questions, and I thought it'd be awesome to capture the process of me learning it, because I'm sure other people will be able to see this on-ramp that I'm trying to take and follow us along. So yeah, that's the plan, and let's just get into it. So the first big topic I want to get into is the very first thing I stumbled into with web programming is that there's just HTTP web APIs everywhere, and they're kind of self-explanatory in a sense. It feels like weirdly structured and stuff, but I'm going to set aside all the nitpicky complaints I would like to have and instead ask about what is going on with this. What are the parts of it that make sense? How can I think about it? So to put a concrete first question on it, it looks like HTTP web APIs are just a thing where you use a string that's kind of like a function name, but kind of not, that you call, but you're actually passing a message to it. And it's asynchronous, so there's a little weird stuff like that. But for the most part, it looks like all you got to think about is there's a point you're sending information to that point. You attach some data onto this thing, and that's all you need to know. But I feel like I wonder if there's low level stuff in the stack below that is worth knowing about, or is it really okay to just use that much of an abstraction in my head to get things done?
I mean, I think that's basically it. There's not really much to HTTP except that it's a particular type of message format that is sent over TCP. It's text-based, although newer HTTP encodings have like a binary format to try and make things more efficient. But it's pretty much just a like message format. The weirdness of it in that like HTTP APIs sort of look like these big confusing function calls, I think is really just because HTTP was not designed for APIs. It was designed for document delivery. So originally all you really had was just the GET request that would get you a document. And then later people, I guess, realized that you could do other types of requests that could actually send data back to the server. And then, I mean, from there, that's all you need. Now you can essentially do whatever you want with that, although it's going through a document delivery protocol.
Yeah, and to expand on that, like different places I've worked and different projects that I've been on, like sometimes we'll only use Git and post will kind of signify like, hey, there's data being sent over. And there is the added benefit of the post data not being sent in plain text, whereas with Git, it just gets appended to the URL.
Yeah.
So there are projects where we just use post for everything that requires data to be sent or changes. But depending on how granular you want to go, you can also then, of course, use some of the other ones like delete, which is pretty self-explanatory, put and whatnot.
Yeah.
But you really don't have to use all of them. Like nobody's gonna come in and smack your hands.
Yeah. The funny thing is there's a few different places where you can put information in an HTTP request, right? There's the verb, which originally was just get and post, but then more were added for, I'm not really sure of all the reasons, but there are more of those now. You can obviously put stuff in the URL itself. That's the like query parameters, and that's what Bret was talking about with data showing up in the URL in a GET request. That's the like question mark foo equals bar ampersand baz equals, that sort of scheme for encoding stuff.
Right.
There's the request headers, which can, there's like a bunch of official headers, but also you can just put your own in there, and who's going to stop you? And in post requests, and really any kind of request that isn't a GET, you can put literally whatever you want in the body. So different places, different people will use different parts of the request for different things. It's just, there's so many places that it's like there's no actual, firm requirement on how you do it.
Yeah. So that confirms kind of most of the intuitions I've built up about it. I stumbled into the thing about there being a difference between GET and everything else. I can't remember exactly how it came up, but one way or another, I was, hit with an error that was like, you can't put a body on a GET. And obviously there was no need for me putting a body on a GET because no one was actually trying to receive it. But I was not aware that in this case, the parameters are going into the query string, and you got to take your parameters and package them up a little differently. And it sounds like the rest of what I kind of gleaned from it is correct based on what you said, Ben, which is it looks like just this gigantic bundle of information. There's the method verb thing. That looked like, besides the fact that GET had a special rule, it was just a little random piece of information there. Then there's the URL, and the URL is, first of all, like it is a domain name, right? It does resolve to an IP address, and that part is significant because it actually tells us where the data is going. And then the rest of it is just a string. Like it looks like a file path, and then it's got a question mark, and it looks like a query string thing after that. But like a lot of that is sort of convention, but it's just an ASCII string for the most part, right? Mm-hmm. And then there's the headers and body, and that part I think is the part that was most intimidating because there's this weird rule where GET can't have a body in the headers. I mean, the stuff that goes on in headers is all like the authorization stuff, and we're going to get into that next. That's another part where I'm a little like, I want to make sure I'm doing this right because some of this involves like, I'll explain why, but it's like, this is where security actually starts making sense to me as an issue. And that is just like, it looks like a free for all. Like every API is like, oh yeah, you put authorize : whatever we say here, and then 5 other random things we made up. And I'm like, wait, is there a standard here, or is this all a free for all? Because that's what it looked like.
The thing that makes GET different, I think, is that part is actually that's the thing that is used for getting documents a lot of the time. So that's the thing where you have caching. You don't have caching for post requests because the implication is that it's, well, I mean, maybe you do. I shouldn't say anything in absolutes, but
by default.
yeah, I'm sure that, yeah. But, with the typical pattern for GET requests is the GET request that the browser makes when it navigates to a page. And so it's going to send a GET request for a particular URL that the user clicked on or whatever. It's going to include a bunch of standard headers, like the user agent header, for example, to identify what type of browser is making the request. And it's going to include stuff about caching and cache policy stuff so that the server can respond with some different things if it wants, right? There's a bunch of stuff around that when you are coming at it from the perspective of, I'm trying to get a resource and a static resource. As far as I know, you don't really get any such mechanisms for any of the other HTTP verbs. And from my perspective, there's hardly any need for the other verbs besides post. They're there, but I just don't see that it really matters very much. I think maybe the people who came up with them hoped that there would be more similar semantics around them, but it was never standard enough for anybody to actually do anything with it. Never standard enough that anyone can rely on it.
Yeah.
Like I said, I actually don't mind. It is a little bit from a design perspective, you could imagine streamlining this and making it feel less like a bunch of random ideas thrown together. But I really don't mind having a message passing protocol that's just we got 4 or 5 different ways to organize information, so long as I have the clear confirmation from someone who's been in the field that I don't need to overthink it. That's pretty much all I need to know, and then I can move on. But this is not that big a deal.
Yeah.
So let's talk about this other part that makes me nervous, which is security stuff. And I'll set this up for anyone who's listening who doesn't know how this stuff works, because it works the same way pretty much everywhere. And when I say security stuff, what I mean in this case is I'm using different services. So I go to someone, they provide something on the web. And so this is why we are dealing with an HTTP API in the first place. It's not because I'm making one necessarily, but it's because I'm using someone else's. And then they're like, oh, thanks for making an account. Now, by the way, if any random person wanted to, they could send information to us and we would act on your behalf as if you wanted us to do this. So the only way to prevent random people from doing stuff using your account is that you've got this secret password. And as long as you're the only one who knows the password, you'll be the only one who can actually get us to do stuff for you on your account. And then it's okay, cool. How is this going to work, though, when I go to use the API? I'm going to have to let you know that I'm me by showing you the password. And then I'm well, hold on. That means that I'm writing code where my password is just being concatenated to a string and sent to you. And I'd like to make sure I'm doing that right so that it's not my passwords are just out there. And I'm pretty sure that the little tutorials I've walked through didn't do the complete wrong thing, but I want to just double check some things here. So first of all, usually this goes in the authorization header. I think that's the only thing I've seen. I don't think it could go anywhere. Is the authorized? Is there other ways that this gets passed along without getting exposed? And actually, you know what? Before you answer that, also answer for me. How does this get passed along without getting exposed, even when it's in the header? How about we start with that?
Encryption.
Yes.
Okay.
So a bit over a decade ago, they introduced this beautiful icon that was a green lock next to HTTP, and it means that it's HTTPS. And if you are sending stuff over HTTPS, that I believe it's both the header and the body are then encrypted. So interceptors cannot actually read the data there. So you don't necessarily even need to pass it as an authorized header. You could pass credentials in the body if you wanted, and certain APIs will have you do it that way. But HTTPS is a big thing that's been introduced to avoid these types of attacks because they were really common back in the day. And I'm sure Ben has some more information if there is more, but I can't think of anything.
I mean, that's basically it. To my knowledge, no actual HTTP messages are sent until the TLS handshake is done and you've got your protocol worked out. and then it's just HTTP. Like HTTPS is pretty straightforward because it's just you do the encryption handshake and then you do HTTP. So everything that you're sending as part of the request is encrypted and should be invisible to anybody in the middle. There's still considerations you might want to make about what's visible on either end, what goes into logs, what goes into browser history, what might be visible to like JavaScript APIs on the page or something like that. But the headers and body of a request are all fair game for that. You know, if you put your password in the URL, then you might see that somewhere in some kind of log if you got access to somebody's computer, but not in the headers and body. And certainly nobody in the middle is going to see anything regardless, as long as you're using and trusting HTTPS.
Gotcha. So yeah, I've done the HTTPS setup thing. That's the whole thing where you get like a certificate and a couple of like a key or two or something. And honestly, I don't know how much of that I need to know super well. If you wanted to go into how that works, I'd be interested. But I feel like if the HTTPS doesn't work, you know you've done it wrong. And once it's working, you just hope you don't have to do this for a couple years or something. Like that's my approach to it. I don't know if there's a recommended way to make this a...
Hope your server renews the certificates for you, right?
Mm-hmm.
But I wish I knew more about that personally. That's something that I actually would like to dig into more. Like one of my like jam project ideas is to just make some kind of better viewer for like certificate chains, because I legitimately have no idea what's going on in there.
Okay.
And my browser's like, do you trust this certificate? And I'm like, how the hell would I know? I click on view more and it's just like, okay, here's 50 random properties. And I'm like, how am I supposed to make a decision about this? So yeah, I wish I knew more there, but.
Okay. Yeah, I think I have another question about this. So with these secret keys, so another thing that's pretty clear is you don't want them in your source code. Right? Like, is that true? Like, I think it would be a mistake to just copy paste all my secret keys into my source code, because I could secure all that in theory and make sure it never gets out there, but it feels like, and most of these services are like, please don't put this in your source code. Mm-hmm. And it makes sense, but all I'm doing is putting it in a file next to my source code and not checking it into Git. And I don't know if that's just what is done, or if it's like, no, there's a really clean way to solve this problem that's secure end to end. Like, what is the story there? Have I done something dumb, or is that the move?
You're definitely on the right track. What a lot of people do is use .edn files or .environment files, and essentially you could ignore your .env files. Most of the time, you do it globally. Sometimes there might be one that you check in, but you can then append more suffixes to it. So .env.production, .env.development, .env.local, and then like a .env, which is kind of the global one that goes for all those, which maybe has stuff that is less secret oriented and more just configuration settings for it that you want across all environments. That one you might check in.
And most of the time, these are loaded into your environment variables on
yes.
whatever platform it is that you're deploying to, right?
Yeah.
So that's where they actually end up.
Okay, that makes sense. I've got that sort of set up. I don't really know how. Is there something special about .env, as in like is it a Linux thing where .env files work automatically, or like languages come with the library for loading these, or is it going to be any text file and it just happens to be convention that it's .env? What's that bit about?
I think part of it is convention, and then part of it is that, I mean, I haven't thought about it in so long because it's usually just set up, but I believe Node.js just automatically will read in one of those files and apply it to.
Does it really?
I think so, maybe.
I need to look this up now.
I want to say yes, but maybe I'm using a package or a library that I set up ages ago and I just never think about. That's the thing with the web is...
Yeah, we had this for an older work project that I had. And I think there I remember us just having some kind of library that would load this. Or it was just like a shell script with a bunch of export foo equals bar lines that was just like, okay, you run that, it's in your environment. To address the earlier thing that you mentioned, Alan, the main thing is just that having secrets in version control history is scary. Because then if the first of all, it's really easy for that to leak out, especially in a system like Git, where if you ever make like a pull request to some repository, you might just upload a huge chunk of your Git database to that repository, and it could just contain the secrets and people can search through it because the contents of a Git repository aren't encrypted or anything. Mm-hmm. It's spooky, right? Mm-hmm. So it's generally just considered good practice to not actually put your secrets in source control, have it loaded in at runtime from somewhere, from some place that, again, won't show up in logs or whatever. Just, and environment variables are a common choice because they're relatively invisible. There are sometimes things that will log all the contents of your environment variables, but generally speaking, that's not a common thing.
Yeah. I think it's also, I'd like to know one other thing about what you were saying, Bret, about having multiple end files, because we haven't gotten to this part yet. It's a part of sort of organizing workflow and architecting these things, but like this idea of having a production and a development split is something I don't do in C programming. Yeah. And so I'm still wrapping my head around how far that has to go and where the splits actually show up in the system. And it became pretty obvious to me at some point that I don't want to have, I was typing, because again, the services I'm using set me up with a test key and a production key. So it wasn't on me to figure out that I needed the split. They're already forcing me to use two different keys. Yeah. And so now I've got a secret test key. And I'm like, all right, I'll put this in my little not source control secret file that says such and such service secret key test. And then I'll have the other one, such and such secret key production. And then I start using it. I'm like, wait, how is this ever going to work? Everywhere I use the test key, the code won't transition over to, I'm going to have to go change the variable over. It's like a silly little mistake. But I immediately realized, no, I'm going to need them to have the same name at some point in the chain, whether it's behind a function or just from a different file. But then I'm like, does that mean I'm going to need to set up two of these files? Or I have two totally, we'll get to this part, right? But that's a part of it that I'm interested in. So it's common practice, I think you were saying, to have multiple of these files that gets loaded in just so you can split up things that are secret and that you want to have two different copies of in different locations, from lots of config stuff that's also convenient to have loaded in, but that you do want to check into the repository so that you're not managing two copies of that. Is that what you're saying?
Yeah. And you can understand then why environment variables are such a natural fit for this kind of thing, right? Something that's going to vary from one server to another. An environment variable is a pretty natural choice for that kind of thing. It's kind of just a mechanism that the operating system already provides for you to do that kind of thing.
All right. One last thing about HTTP, and I'm pretty sure this is a nothing burger, but correct me if I'm wrong. A lot of services like to advertise that their HTTP REST API is a REST API. And as far as I can tell, I can ignore that and still understand how to use it just fine. Is that correct? Or is there something I need to know about REST APIs?
It's a paradigm is kind of what I would say at the end of the day. Is that correct, Ben? Usually when I see the word REST, I'm just I don't care.
It had a meaning. It had a meaning to the person who coined the term. And then it rapidly lost that meaning to the rest of the world. So at this point, REST API means HTTP API. Maybe it means it's more likely to use more of the HTTP verbs than just get and post. But it doesn't actually mean anything. Okay. The actual meaning of the name is, let's see, I think it was Roy Fielding was the guy who coined this, and it stands for representational state transfer, and it's supposed to have these properties of statelessness and hypermedia, and the server is the owner of the state, and hypertext is the engine of application state. There's a bunch of very large conceptual ideas out there that are theoretically what REST is supposed to be. And whenever you see anybody advertise a REST API, none of those are there. Mm-hmm. That just doesn't apply.
Yeah. I tried to wrap my head around it, and I was like, this looks like it must be marketing buzzword something, because I see that the definition says something about stateless, but every single one of these APIs is create new user, create new thread or something like that. And it's where's the stateless here, guys? And then the other part is I do see that a lot of these, when I think API from a C perspective, a lot of times you have reasons to do stuff like, oh, I'm going to need to have like a begin and an end, and then special stuff can happen inside a begin end. HTTP APIs like never do this, because I can think of reasons why this wouldn't happen, but it's a message passing thing, and you wouldn't want between two messages to figure out who did this begin and end and like correlate. A lot of these seem to be like agnostic to who the sender is. They're just like, whoever is sending this to me, as long as I like the key on it,
Mhm.
I respond to them, but I don't care who they are. You could send the same thing to me from 100 different locations, and I would respond the same way. That seems to be the way they're structured. And so you don't get things like begin-end pairs. And I thought maybe that was what the REST thing was saying, is like, this is an API that does not respect who the sending IP is, but I was not sure.
Yeah, that is a practical aspect of statelessness. I guess maybe one thing that does differentiate it. This is mostly, I mean, this is just speculation on my part, but I think maybe the modern REST API is in fact more stateless than the APIs that came before, because what was more prevalent before was a sessions sort of approach where you authenticate, you get like a session cookie, and then that session cookie identifies you on all subsequent requests, and then you can have very easily lots and lots of state on the server. Whereas your typical REST API does have some notion of statelessness to it, where it's just at any time you make this kind of response, I do this kind of thing, I send you this kind of, did I say response? I send you this kind of request, I do this thing, I send you a response, and that's just always how it happens, regardless of what came before, regardless of what came after. So I guess there may actually be a practical element of statelessness, but at this point it's so much the norm that it maybe doesn't stand out.
Okay. Yeah. That I wasn't a web programmer when sessions were a thing. I haven't dealt with that at all. So I didn't even know that was a thing. It was just a speculation on my part that maybe this was...
Yeah, cookies are a whole thing.
Yeah. I don't have that on my list today. I can only fit so much into my brain in one session. Yeah.
You hopefully won't need them if you're a consumer of these kinds of APIs.
All right. I think that wraps it up for HTTP stuff. The next big topic, we're building up building blocks here. So for anyone who's following along who, like me, hasn't touched this before, that is sort of the first thing that you're going to run into, is that you got to learn how to get and post on these things in order to start interacting with the web. Otherwise, like, why aren't you just, like, you're doing something on the web because you want to use one of these services, or you want to interact with something else that's already on the web or something. So that's the first big piece. But then the next piece is that, and this isn't like necessarily required, you could do simple stuff like a chat bot without this probably, but a lot of stuff is geared towards using a database for your memory, especially if you're doing things like tracking people who have an account with you or keeping a log of anything. And the basic explanation is that, you know, you have concurrency going on the web. So you can have two different people talking to you at the same time. And, if that's happening, you might be making reads or modifications on the data, and you need some kind of extra layer between you. You can't just be using a file or your RAM, because these are going to get corrupted in all sorts of ways. So the database is like, hey, I'm going to give you a different interface to memory that prevents all of that concurrency stuff from corrupting anything. That's my basic understanding. I don't know if that's completely accurate, but that's all I really understand about why to use a database. So the first question is, are there other good conceptual reasons why web stuff tends towards databases besides just that one little low-level issue?
I mean, persistence is also an important thing, right? Like, you do need the data to actually be saved somewhere. Databases are resilient to, like, program crashes, you know, interrupted writes. You know, if something falls over halfway through writing, and you want to be able to recover the data when it boots up. So a lot of that is just inherent to, like, running a real service where you don't want to lose customer data. I mean, I think probably a lot of the practice around databases comes just from that. But the concurrency thing is huge, like you said. Certainly you will have the guarantee, basically, of multiple people making requests to your service at the same time. You also might well have multiple copies of your server program running at the same time, in order to, you know, be redundant and avoid load problems where, like, the, you know, one process gets jammed up and you need to keep uptime while restarting it or something, right? There's all these practices in real work around like keeping the service up and running smoothly with as little downtime as possible. So a database layer also helps smooth over a lot of that.
Mm-hmm.
And I guess then there's also just more business concerns of like data integrity, the sorts of things that a relational database gives you, where you can guarantee that you have a foreign key from one table to another. You can have transactions so that you don't write only half the records you wanted to write. You know, a lot of it is just sort of practical businessy reasons more than technical, though.
Yeah. And then in addition to all that, databases also provide a way of querying that data straight from the get-go. You can also easily export all of your data. You can import all of your data. So like there are a bunch of shortcuts that you have there that you don't have to program yourself because they are built into the database, whether it's a relational database using SQL or one of the newer NoSQL. Well, I can't even call them newer anymore. They've been out for over a decade. But yeah, like NoSQL databases that are more object orient or object document based. I don't even know the terminology for it, but querying and having the data stored well.
Well, it's hard to pin it down because the only defining unifying characteristic is that they sure aren't SQL. So
fair. Yeah, databases give you a way of organizing and accessing your data quickly with minimal like programming, and yeah, so you just get all these shortcuts and hopefully performance gains if you pick a database that is right for your use case, which in the beginning isn't something you really need to worry about, but as you learn more and more about different like databases and how you might want to access data, it might make more sense to choose one over the other for performance gains or easier relations between the models.
yeah, I expect, Bret, that that's something you've had a lot more professional experience with, the like database tuning and like larger scale kinds of things just from your line of work. I don't think I've ever worked on anything that had such a large user. I mean, it's even the web dev company that I was at before had a very healthy size user base, but you can just throw one of those like cloud hosted relational database things at it and it works just fine. Like you have to be at such an insane scale for one of those to not work. And you still, you know, you need people paying attention to your index performance or whatever, but it's still not actually that crazy.
I think, yeah, a lot of the stuff you were saying, Ben, was my understanding that it's this layer of the database provides, in my head, it's like low-level issues that you just want sorted out in like a fault, like no, this cannot fail sort of mentality. Like this bit here just cannot be allowed to fail, so that gets separated out. You don't program that. It's kind of like you don't roll your own cryptography. You also generally are like, I'm gonna put my data into something better than a file that I serialize myself because I actually care about never losing it and stuff. What you mentioned that though, Bret, I guess I knew this intuitively, but I had it flipped around in my head. So I'm a C programmer, and in my head, it's like if you give me anything other than an array of bytes, you've complicated the issue. It's like the simplest data is just an array of bytes. And this database thing, it's like the fact that I have to use a database like data structure is just the unfortunate consequence of having that low-level stuff sorted. But what you pitched is a flip of that, which is like, no, actually, you want tools that can browse and use the structure right away so that you don't have to write all that serialized. It's like you can start viewing your data, you can start querying on it. It's structured in useful ways right from the get-go. And I guess I have to think about that. That for me as a C is like, is the opposite of what I assume, but it makes sense in a certain way. It's like it's a data with structure with interfaces on it already. And that also, it's like it should have been obvious that that was actually a part of the value add, because the next question I'm getting into is basically we're going to zoom in a little bit more on, because I'm picking your guys' brains here today on this stuff, and I am building a thing, but I don't need that much out of this, right? It's like it's not going to be that, like, while I said concurrency is happening, it might not happen for a long time for me. I might not get the two overlapping requests for a while. If the thing keeps running the way I hope it will, it might be a while before that happens. Nevertheless, I would like it to not, fall over the first time it does happen. So I'm thinking that the important data will go in a database, but I'm looking for a solution that is as simple as possible, because quite frankly, after I've tried to set up a MySQL database and a Postgres database, I was like, there's a lot of ways to waste a lot of time tinkering on this, and I want to get off of it. So I'm going to get a little more specific here on this one. The setup I've got right now is an SQLite database, and that is cool, but SQLite doesn't come with any networking capabilities. So what that means for people listening is it's like a SQL database. Also, I pronounce it wrong all the time. It's SQLite, not SQLite, but like it says SQLite. I'm sorry. See, I've got a SQLite database. It's really just a local program. So no, it doesn't offer any way to connect and deal with it. It's just your local programs, local data. It provides all the data integrity stuff. It provides all the querying stuff, but it doesn't give me a dashboard. So like, back in the day when I would do like I'd download a LAMP thing for my Windows, they would automatically set up MySQL for me and give me a dashboard for playing with my database. It's not like that. There's no dashboard. There's no way to change the data unless I stop the program and grab a copy of the file locally and get some kind of third-party tool that can look at it. There are some like sort of okay tools that sort of try to sit on top of the file and let you look at it from outside, but you kind of have to set that up yourself and configure more stuff that way. So I'm curious if you guys think I'm on the right track for a really small thing that I don't think is going to need that much database stuff, or is there other easy ways to solve my data integrity problem where all I want in addition to that is sometimes to look at the data and tweak it without having to stop the program?
I think SQLite's a really good choice. I have spent a lot of time suffering trying to manage a Postgres instance for the Handmade Network website. And it's astonishing how difficult it is to do the administration of the database itself correctly. Like, even just getting backups to work is shockingly difficult. At some point when trying to restore some kind of backup for Handmade Network stuff, I discovered that it got stuck halfway through the restore and wouldn't keep restoring because we had an integrity constraint between two of the tables where it's like the data in this table has a foreign key to the data in this other table such that you know that there is a record on the other side. But while you're restoring the database, as soon as you write this table, it's like, no, the integrity constraint isn't met. This table doesn't have any corresponding rows. Therefore, I refuse to write the data. And it's like, no, you're restoring from a backup. You're going to do that table next. You can't wait until the tables are all restored before you just start doing the integrity checks. I don't know how that's the experience for this professional database product, but it is. So, I really do not recommend that for any kind of small hobby, getting started kind of process. You can avoid that if you use a hosted cloud Postgres thing, because then you just get the URL or socket that you connect to, and they're doing all the backup scripts for you. You don't even have to think about it, but they do tend to be pretty expensive. I think SQLite's solid.
They might even make money off of your data if you're lucky.
Yeah, read the terms on that one, I guess. But SQLite is really solid. And to my understanding, you can have concurrent access to files with SQLite, which should allow you to hook up one of those SQLite viewer editor kinds of programs and actually work with the database even live if you can get that going.
Yeah, so I guess maybe this is just looking for, at this point we're just looking for if anyone has experience with a good one of those. The thing I found is there are a lot of viewers for SQLite that are not web. They're like, hey, SQLite's not a networked database, so why would you need networking? You just do it locally. Mm-hmm. And it's like, well, hold on. It does support concurrency. You're right. That's a big part of it. Is it's not optimized for concurrency, but it does not fall over when you use it concurrently. And so for my use case, it's that should be good. But that means I need to find one of these viewers that is willing to be networked, even though SQLite advertises itself as non-networked. Yeah, I'm just I don't you guys do this all the time? Isn't there something you reach for? But maybe it just is rough out there for setting this kind of stuff up. It might be the answer. I don't know.
Yeah, what I usually reach for is I have XAMPP, XAMPP running on my computer, and that comes with MySQL. So most of the time when I'm working on my own stuff, I just user web interface there. Don't really have to think about it.
Yeah, that's fair too, because those kinds of all-in-one setups do tend to come with some kind of dashboard and tend to help with a lot of the like administrative difficulty too.
Yeah.
So
yeah, I never did any serious web programming, but I definitely have installed XAMPP for some reason before and had the experience of like, oh, look, databases are cool. They're like spreadsheets, but with columns that are typed. And then didn't know how to web program and gave up. But like that was an experience I've had that set my expectation that like I deserve to have a web dashboard for my database is how I feel.
that's true. I do miss it. I always use Postgres from the command line for handmade network stuff, and it makes me really sad compared to like what I started out with, which was like a PHP myadmin thing,
Yes.
some shared web hosting thing. You know, like it wasn't amazing, but like it is better than using the command line. So
Yeah, so I think that that's all I can get out of hoping you guys have the diamond in the rough for me. It sounds like I might be on the right track with SQLite for my use case. We'll get into some other stuff that I'm worried about regarding like concurrent access that might be relevant. But tell me a little bit about the security side of this. So a funny thing that I started realizing is if I'm going to have a thing where, say, someone can enter a text field, the name of a thing, for instance, an account that they want to create, and send it to me, if I just take their string and go, that's what an SQL, well, that's what a SQL injection attack is, basically. Or like, I just take that and paste it into my own, like if I have a SQL string with a template and I'm going to take their string and plop it in, that's where if they get lucky, there's a chance to make other stuff happen, right? Or is it more complicated than that?
That's it. Yeah, they basically are taking advantage that you're just concatenate or like templating a string and putting it in, and they're like, well, I'll just write the rest of the SQL for you, and whatever you had there will just not get read correctly, and it will continue.
Yeah.
It'll run everything up until there.
yeah, well, it's funny to you've probably seen the XKCD little Bobby tables thing before, right?
No, I don't think I know what that means.
Okay, if you search for XKCD, I'll pull it up here because it's a concise little thing that actually kind of is an amazing example of how SQL injection works. Like if you know a little bit of SQL syntax, so it's XKCD 327. So I'll spoil the comic here, but basically like the joke is that some mom, when registering her kid for school, did a SQL injection attack on the school. And it's hilarious. But the third panel there, did you really name your son? And then there's this chunk of SQL. Robert, end quote, end paren, semicolon, drop table student, semicolon, dash, dash. So if you can sort of parse what's happening here, she's writing the name, closing the string, ending the query, writing another query that deletes all the students, and then starting a comment. So everything further is going to be completely ignored. Yeah. And then, that's all it takes. So, yes, that kind of thing absolutely can happen, and it can actually be that easy if you are just naively pasting text into a SQL query. This is such a widespread thing, or it was such a widespread thing, that any libraries used for querying SQL databases these days will almost certainly not be designed around that. They will be designed with some kind of placeholder system. They'll have some kind of prepared statements where you can like sort of parse and prepare the query ahead of time with placeholders for values, and then the library can just like insert values for that. And it's not actually doing string concatenation at query time. There's like a different protocol around how the query happens.
Okay. All right. That is good to know because yes, that makes a lot of sense. This was one of the things where I was getting it wrong, and it's good that I picked your brain. So we haven't gotten to talking about Node.js yet, but I'm in Node.js, and the library I'm using for dealing with SQLite comes with this weird feature where it will autofill strings for me, even though JavaScript already has a string templating system.
This is why.
So I was like, I'm ignoring that and using the string templating thing. And then it occurred to me that I might be SQL injected, and then I thought I should ask you about it. So yeah, I just got to go with what the library does to protect me from that.
Yes, that's exactly why. Because then you're funneling it through, at the very least, you're funneling it through a system that can consistently escape strings, right? It can consistently escape all the quotes and escape all the special characters so that even if it were just pasted into the string, it wouldn't at least be parsed directly in a SQL. But more likely, I mean, I'm actually not sure if SQLite has something like this, but
I can go to check, but now I know what I'm looking for.
But yeah, databases like Postgres are designed with, like I said, other protocols of queries where like you don't even have to do the parse at query time necessarily. You can like set up the query ahead of time so that all the actual queries later can be more efficient.
This is one of the many places in WebDev where I would say, let a library handle it for you. Let somebody else handle it for you. Much like how you don't need to write your own certificate. Like, go use Let's Encrypt to go create your HTTPS certificate. Like, don't just let them handle it. Let them do it and handle all the 5 billion edge cases that you might not know until you run into.
Yeah, I definitely do not. If I was going to be a professional low-level web programmer, I would go learn how to escape a SQL string for a SQL library sooner or later.
Yes.
But I'm so not interested that I'm happy for a library to solve this for me. I do, and I'm glad. I think Ben kind of already made it clear. But my follow-up question was going to be like, wait a minute, how is the library doing that? And is there anything I need to know? But it makes sense if it's just like, this is just string escaping.
It's at least that. Mm-hmm. While we're on the topic of SQL injection and common security vulnerabilities, one really valuable resource is OWASP, OWASP. They are like a security organization, sort of a like industry group that tries to collect advice and guidelines on how to approach a lot of these security things. They have a top 10 list, like the top 10 security issues in web software, or it might be more broadly like enterprise software or something. But SQL injection was for a very long time very high on that list because it was so prevalent in so many tutorials and so many libraries and so on. Like the way that people were making database queries was very prone to SQL injection and relied on programmer diligence to avoid. Like, don't forget to escape when you're putting stuff into a query, and of course people forget to escape.
Yeah.
That has gone down, I believe, in recent years. But there are other things, like we could get into cross-site scripting as a bonus topic at some point, but maybe for later.
So where I thought this conversation was going to go, this is just more of a reflection on my part now, and I think sort of appreciating how valuable this insight you just gave me is going to be, where I thought this conversation was going to go is like, here are the best practices, quote unquote, that are like, whenever you receive a variable, immediately escape it, or no, wrap all your SQL, it should be it's like, in my head, I'm immediately thinking there's some point in the pipeline that's a choke point, and that's where I'm going to make sure that all the usernames don't have spaces in them or something like this. And you're saying like, no, actually, we already tried all that. That was all crap. We solved it. The library doesn't now, right? That's the way that we made it good. And that's really good to know, like, that there was a time when this was a problem. There was an exploration of where do you put the solution that minimizes the issue. And here it is, because I need to be caught up, and I don't know. I'm just appreciating how useful it is to get that little tidbit.
Yeah, it is the kind of thing, at least for SQL injection, it is the kind of thing where programmer diligence is not really sufficient, and you can design better things that make it less likely for people to make the critical mistakes. I do actually, though. You're talking about security choke points and stuff. I don't think not everything can necessarily be so easily solved through. Well, actually, this is another example. I want to talk about cross-site scripting. Okay,
let's do it.
It's not that complicated. Let's because it actually is sort of similar to a SQL injection attack, except on other users of the web application. So imagine if instead of in the XKCD comic, she put a bunch of SQL. What if she put a bunch of JavaScript? And then what if, when the web page renders somebody's name, it just splats the name onto the page, and there's a bunch of JavaScript now that runs. So that's called cross-site scripting. Mm-hmm. That's where you can put some kind of code, a malicious payload, onto the server. The server will deliver it to other users, and that code will run on other users' computers. So this is another really common one, and one that I think isn't necessarily as easily solved by libraries. I mean, you can certainly, if you have rules about no special characters, that'll probably do something. But there's also some really dumb, like, you can look up something called JSFuck if you want to be entertained. It's like it's JavaScript brainfuck, where like there's just this really minimal set of not very special characters that, thanks to all of JavaScript's dumb rules, can be used to do arbitrary JavaScript things, where it's like, oh, if you negate an empty array, then you get the number 1 or something. It's like nonsense. And so you can use this to chain into evals and stuff. So
sounds fun.
It's very, very goofy, but it is to some extent something that is sort of solved by libraries too. Like if you ever use React and you try to, so there's a DOM API, a browser API called inner HTML, where you can just take any element and set the HTML that it contains. Mm-hmm. That's a very natural way that you could achieve cross-site scripting, right? If some site it's making a request to load up the list of users, and then it's going to the name element on the page and setting the inner HTML to the name. Well, if you put a script tag in there, then you can do JavaScript stuff. A framework like React can like try to discourage that, and it looks really goofy in React because rather than give you direct access to that property, they have this API that's called dangerously set inner HTML. So that if you ever actually want to do this, you have to type the word danger, and if you ever try to put it in a code review, then somebody would be like, why are you doing something dangerous? So it's not as elegant, but this is how people try to solve these things, right? This is how people try to work around the diligence problem.
Fascinating. Yeah, I don't know if that will affect me in any of the things I'm doing, but I think I should go read the OWASP thing, because there are probably stuff that I'm not even thinking of that are also relevant, and that sounds like it might get me thinking.
They can get subtle and confusing, but yeah, it's good to have as a resource. The other thing that OWASP does is they have a cheat sheet series where just for lots of different things that you might want to do, like store passwords. They're like, okay, before you store passwords, just read this, right? And we're going to recommend you a hash function, and we're going to update this every year with what we think the best hash function is. And make sure that you're salting your passwords with this type of salt, and make sure, So it's a useful thing to check if you're ever doing something where you're like, this seems like I'm out of my depth and I don't want to mess it up.
I like that. That's good to know.
I would like to append one thing to the cross-site scripting, which is iframes. So you can basically embed another HTML page inside of an HTML page with an iframe. Now, you used to be able to then, from within that iframe, be like, hey, so who's hosting me? And what if I go execute JavaScript on that site instead? And in recent years, I don't know the current status of it, but web browsers now basically sandbox that off based off of certain rules. And I know some of this is like set within the host website saying like these websites can have access and these websites cannot. And I believe by default it says don't allow anything from an iframe unless it's from me. So one thing to be aware of is that browsers have implemented a lot of security things, which in some cases have broken functionality of certain things, but for the most part, they try to make sure that whenever we introduce new things to JavaScript, to CSS, to HTML, to the way that the web works, that it is backwards compatible.
That's all fascinating stuff. I'm going to take us away from security, but it's to wrap up my database questions. And this one's maybe a little more open-ended. This might be a question that can't be answered. It's like I said, I'm a C programmer by day, and I'm used to dealing with data by being like, here's my array, and let me tell you how I'm going to lay things out inside there. And so I have some intuition about what I'm going to do with a database. Like, it's kind of like a bunch of arrays of structs. That's as close as I can get to how I'm going to think about it. But I feel like I would like to just get is there some way to go about learning how I should think about crafting my database structures and the queries that I put on them? And I know Ben has done like a whole thing on trying to make queries easy to create before. So I don't know if there's any way that I can use that or similar. Like, how do you go? Like, I find SQL or sorry, I find SQL relatively difficult to write.
Yeah, it's bad.
So I don't know. What do I do?
Well, I mean, God, it's really funny that for once we get to come at it from like, well, a relational database is sort of like an ECS. You know what an ECS is? Because like typically it's the other way around, that it's like, well, an ECS is just like a relational database or struct of arrays or whatever. I mean, yeah, a database table is you already know the structure of a relational database. You have tables that have a fixed set of columns, and then you have rows that just have each of those columns in them, and that's the structure, right? So it generally speaking, the idea of a relational database is to, through the query system, the query planner, etc., abstract a lot of those details away from you so that you can kind of query it in arbitrary ways and get decent results pretty much all the time. That's kind of the idea. Now, you'll still need indexes for some things. I guess the sort of data structure mental model that I would give is that the base data storage is this like array of structs. And then layered on top of that are B trees.
Okay.
Where, your primary key, you know that like a database table will almost always have a primary key. So often some kind of ID. And that ID corresponds to some kind of index structure, which is typically something like a B tree, where you can, I guess it's log base something time, look up any record. The way that works is that the records in the database are actually sorted by that key. So the B tree structure allows you to then like quickly, let's see. Maybe there's multiple types of indexes. But the thing I'm generally familiar with though, you'll have it sorted by some key so that you can use like a B tree index to find a particular point and then scan a range of the table efficiently to fetch a bunch of related records. When you create more indexes in the database engine, those might just be another B tree index that like is another way for you to jump quickly to some specific record based on some other key. Or it could be like an entire copy of the table sorted a different way to make another type of scan operation more efficient.
I think there's a piece in there that is, let me back up and come at this from the angle that I have at it as a C programmer, is that if I think of it as simply an array of structures, then if I want to do something like find one structure in there that has a string field that matches a string that I'm looking for, right? And then grab that record and grab other stuff off of it. If I was the C programmer looking at that thing, the first day one, I would be like, let's write the linear scan, and then be like, well, if this is going to grow a lot, then let's switch to hashing that or putting a different kind of searching indexing thing on that will help me get to the string faster. And when I'm thinking about a database, it sounds like you are saying that I need to think about it in the same way, except that instead of building my lookup data structures, I just say to the database system, I'm going to do lookups on this field, and they pick a way to optimize that.
Yeah. So like when you do when you create an index in SQLite or in any other type of database, it will create some kind of more efficient lookup structure exactly like you're describing.
Okay.
And then that'll be available for the database to use whenever it needs to do some particular kind of query. And databases have a query planner that will attempt to make the best use of the way that the base data is sorted, the indexes that are available, in order to do the most efficient type of query that it can.
Mm-hmm. I think I'm not familiar with query planner, whatever that is, and that...
Well, so the way that you described it, like, you described that, like, if you want to look up just a record with some particular string, and it's not like a special column, there's no indexes, nothing, you're going to be scanning the table. Because what else could it possibly do? if it's not already sorted somehow by that, if it's just all random order, like it couldn't possibly be anything but a scan. But if it was sorted by that key, then it could do a binary search, even if there was no other indexing structure, and that could probably help. Or if you have some kind of hash map lying around where you've actually been hashing the contents of all these, then you could use that to jump you straight to records that have that and search through those. So the database is going to have techniques like that it can use, but ultimately you can throw any SQL query at it, right?
Gotcha.
And it needs to be able to handle basically any query that you throw at it. I mean, really, that's one of the selling points of a database like this, is that flexibility that you get when querying it.
Mm-hmm.
So in order to do that efficiently, you need some kind of system that can, especially as you start joining tables and that kind of thing.
Right.
You need to put this sort of declarative, I want this collection of data, into some kind of procedure that can use the data structures efficiently.
Yeah.
And sometimes that can only do so much, and you'll need to recognize hotspots, create indexes on things to give it more tools to work with. But
I'll say, I think that is becoming a little more clear to me, because I've literally only ever touched database programming, so like SQL queries, in the simplest possible way, where like I've gotten to the point several times in my life where I write a SQL query that scans a table for a person's username and returns to me their user ID or something like that, right? Like that thing I've done. And I've been aware and afraid about the fact that there are ways to compose these for basically forever, because it looks like a totally different way of thinking than I'm used to. Because if I was writing C code and I was like, okay, I've got this giant log and it tells me when each entity in my game did different kinds of actions, and I want to figure out which entity did this action between this and this frame, I'd be like, okay, hold on, I'm going to be doing that a lot. So let me think about how this is going to bucket these things. And I'd go into it and like figure that out. And to me, that's like an insane amount of work, right? That is serious. And the thought that the database might be doing anything like that automatically is kind of mind blowing. And I'm sure this is like a thing where it's like, no, this is why we have game programmers, because they do something the database won't do automatically. But the databases are doing something to like do these compound things. And I think I maybe this is more my C programmer DNA showing through, that just like, should I really be using this without asking every question about how they make it work? And probably for my project, the answer is yes, but maybe I need to make a project to go and implement my own database now so that I can stop being so worried about how it works.
We've had people in the handmade community strongly recommend that, and I can find some of those resources afterward. I have not gone down that rabbit hole myself, but I've heard that it's very enlightening and very informative about how to work with data efficiently and reliably and so on.
That's it for part 1. In part 2, we get into architecting a web server, building an effective workflow for a web server, and some miscellaneous stuff like Docker containers and OAuth. If you want to hear about any of that, go check out part 2.